Just in case you haven't done my course, The Foundation for CNC Programming, in which case, go and get it. I'm going to run over the basic G codes, M codes, and different concepts that I use throughout this course. This is G00, the most basic of G codes. We use it to rapid traverse around the machine when we're not cutting. For that, we just need to give the G code and the positional dimensions. G01 acts similar. The only difference is we need to define a feed rate. G01 is used for cutting material in a straight line. To machine radiuses and arcs, we would use G02. G02 cuts in a clockwise direction. For this, we have to state the endpoint of the radius and define a feed rate. The R value is the size of the radius that we wish to cut. If we move our cutter to the start position of the radius, we can define the center point by using I and J values. I is the value of the x-axis to the center point of the radius, and J is the center point on the y-axis. These are both taken incrementally from the last position of the cutter. This technique makes machining compound radiuses and blends possible. To machine in a counterclockwise motion, we use G03 instead of G02. Everything else remains the same. In the safety line, I add the G code to G90. Now G90 tells the machine we're using the absolute coordinate system. This means we have a fixed datum on the component and all dimensions run from that datum within the program. G91 is an incremental measuring system. This means all the dimensions are taken from the last known position of the cutter. There's two more G codes that I need to mention, G20 and G21. G20 puts the machine into the imperial units measuring system, and G21 puts the machine into the metric system. At the beginning of each section of program, you'll likely see this in my programs. Let's go over it so you know what it all means. N1 I use as a search function. We used to use N numbers on every single line in the old days. Now we just use them occasionally so we can search on the machine easily to each separate tool. If we type N1 and the down arrow on the control, the FANUC control system will search for N1 so we can find our tool easily. The T0101 means tool 1 offset 1. And in brackets we can add an operator's note that the machine doesn't read. This is purely for the operator. Below this, we will put an M06 to do an automated tool change to put the tool from the carousel into the spindle. And the S500 sets the spindle speed of the machine. We would normally follow this with an M03 to turn on the cutter. Now we have cutter compensation. Cutter compensation is how the machine knows the radius of the tool. This is so we can program to the shape of the component on the drawing, and the machine automatically offsets the cutter by the radius amount, so we cut the profile at the right size. G41 turns on our cutter compensation by offsetting the tool to the right of the material, and G42 offsets it to the left. The G code G40 cancels cutter compensation. Different machines have different ways of defining what we use for the radius for cutter compensation. The more modern machines would have a tool table and the information sits within there. You might find other machines, such as desktop routers, have a value after the G41 or G42 G code. This tells the machine the diameter of the tool and how much to offset it by. And finally, here is a list of M codes that I used during this tutorial. M00 stops the machine. This cannot be overridden by the operator. There is many reasons why we would use M00 within the program. It could be for inspection purposes, or maybe to check if the cutter is damaged. M01 is the optional stop option. This allows the operator to stop the machine at this point, if he wishes, by using a button on the controls. To turn the spindle on in a clockwise direction, we would use M03, and to turn the spindle on in a counterclockwise direction, M04. M05 turns the spindle off. To perform an automated tool change, MO6 is used, and to turn the coolant on we use MO8, and then to turn the coolant off, MO9. M30 tells the machine that the program has finished and it will rewind it back to the start. This lesson was intended to be a recap of the basic functions of a CNC machine. For more information on this, look into my course, The Foundations of CNC Programming. This explains these concepts in greater detail.